chamber?
Deoxygenated blood, right ventricle.
Right ventricle, and what type of blood?
Deoxygenated.
Okay.
Right atrium. Deoxygenated. Oxygenated.
Is Adam the only one who knows that one?
I know.
Okay, what's this blood vessel?
Aorta.
Okay, what type of blood is in there?
Oxygenated.
Okay, and where's it going?
The whole body.
Good.
That's pulmonary artery.
What?
Veins.
Pulmonary veins, good. So, what direction is blood moving? To the what? To the heart from the lungs. And so what type of blood is in there? Oxygenated, good.
Whoa, wait.
Whoa, wait. Veins come to the heart, arteries go away. So even though this is a vein, most of the veins in our body are deoxygenated, but this is the only one that's oxygenated because it's coming to the heart from the lungs with fresh oxygen. Yes. This whole side, yes, there we go. All right. So, what's this? Superior vena cava, what type of blood is in there? Deoxygenated, all right. And where is that bringing blood from?
The upper body.
Yes.
Arms and head.
Mm-hmm. This,
Inferior vena cava.
okay,
That's the bottom.
all right. And what type of blood's in there? Deoxygenated, because your body's done used up all the oxygen, right? Okay. Pulmonary artery. It's going away, A and A. What type of blood is in there? Deoxygenated. So this is the one artery in your body that's going to have deoxygenated blood, because it's going to the lungs to get rid of the carbon dioxide and pick up oxygen. What valve is that? Okay. And what type of blood is moving through there? Oxygenated. Okay, and what type of blood is moving through there? Okay, and what's the other name for the bicuspid valve? Mitral, yes. And tricuspid, you're going to get a tray, gloves, utensils, get a heart, bring it back to your table, and you're going to find all of those things. So, there's your two. Now notice that the septum doesn't go straight up and down. It actually runs at an angle. This is the aorta. Look how huge that is. Yep. And then there's the pulmonary. Look at how, see these valves? These are your bi and tricuspid valves. See how they're like flaps with little strings? Now look at the thickness of the wall of the right. Look at, yeah, why is it so much thicker on the left side?
It has to pump it through the aorta, which goes through
The whole body, and this only has to pump it how hard, right? So the space inside really isn't any different. The reason why that left ventricle is so much bigger is that it's got much thicker, more muscled walls. So here, what side? What's what?
Dude, that's really what that is.
What side is this? Okay. So the left side has what kind of blood in it?
oxygenated.
Okay, right side has
Deoxygenated.
There we go. Okay, so it's not square, but it's still going to work the same way.
Okay, so if this is
So now I look through. Okay, there's your two AV valves.
The right side? That's the right side?
That's right. It's
Look at the thickness of
like
the
this is a
wall
person.
of the right
It would be his right.
compared to the left. Which one's thicker?
That is on top.
Of which wall?
Right or left ventricle?
That one's thicker.
Yes. Why?
Which one's on top?
Because of the blood.
Which,
I don't know.
what,
Where's it pumping blood to?
the pulmonary, what are you talking about?
The body.
Yes.
There's so many parts.
Where's this side
of
pumping?
What are you talking about?
The lungs.
Okay, what's farther away?
The body.
So what needs more muscle,
left
more,
side.
yes. Okay, does that make sense?
Yeah.
All right.
You're supposed to have it on
Look
the
at the flaps.
paper towel. It's what.
See how
we did,
these
'cause it kept, like,
are like little
sticking and
trap
wrapping up
doors
into
with the little strings to pull
Hey,
it
dude, I
open
didn't
and
do
flap
anything
shut?
except for get
Yeah.
the supplies.
Okay, can you see why these are called semi-lunars? See how they look like little half moons? But they're actually little pockets. You have 1, 2, 3 little pockets built into those walls. And so then when it pumps the blood out, it pushes them out of the way. But then when the blood tries to run back in, the pockets catch it. It doesn't let it get back in.
This thing started beating for like.
Okay?
Yeah.
All right, so go ahead and open that up so you can see inside there. Okay? And see here, see when that slams shut, see how that opens that up?
And which ones make the love dub sound?
The love sound is your AV valves, so the trapdoor one's going shut. And the dub is the semilunars catching.
Okay.
Okay, all right. All good?
Oh, yep.
You got
When it comes out the aorta, it just pushes those semilunar valves out to the side, out of the way. But then if the blood tries to run back in, it gets caught in those little pockets and it catches. And so when the blood catches in there and then pushes it out of the way, it catches, pushes it out of the way, it catches, pushes it out. So they work very different. Those semilunars work like this, whereas the AV valves work like that. Okay? That's some bruising just because of the trauma of cutting the heart out of the poor pig.
Are their hearts bigger than
About the same size, actually, yeah. You look at your fist. So, yeah, that's probably about right for you guys. For us girls, ours are probably just a little bit smaller. But that's one of the nice things about doing pig hearts is that is very, very close to the right size for us.
Could you transplant a pig heart to it?
No, but they do use pig valves to replace faulty valves in people. So these, like either these flaps here, okay,
That'd be
they can
hard to
replace
remove
those.
without breaking
Yeah,
it.
well, they just very carefully take that out of there, okay, and then also the semilunars, that tissue is able to be taken out and put in. So if you have a faulty, usually the mitral valve is the one that's,
The mitral valve, which is the bicuspid.
correct, yeah. But they will use pig valves to replace ones that are not working in us, because they're just the right size. Pretty sweet, huh? Isn't that cool? Yeah. We are going to see how well you know your circulatory system. So I'm going to give you a name tag that you're going to put on. And then you're going to come up here to the front. No, hanging around your neck, that's who you are for the next 5 minutes. And you need to come up here and put yourself in order. There's a body cell. So blood and body cells, how's it going to get back to the heart?
Wait, chest in here.
Your daddy's going to be over there. Okay? There we go. There we go. Everybody look. Does it go straight from here to here? No. Okay, I'll three. Okay, but where should just a plain old regular body vein be?
On the way back, right here.
Uh-huh. Hi. Okay? So, everybody look. Now are we in order?
Yeah.
Are you sure?
Yep. If you say so, maybe.
Okay, so if we start with blood coming back from the body, what are you?
Superior vena cava.
Right atrium.
Right ventricle.
Pulmonary artery.
Lungs.
Pulmonary veins.
Left atrium. Left ventricle.
Aorta.
Artery. Body cell.
Vein.
Okay, so we made it all the way around. So now here's your blood cells.
Oh.
Oh, and we're gonna start passing blood in the order. Oh, what direction?
Oh.
Who do you hand to? Okay.
We need blue ones now.
Okay, no. Okay, and you are gonna start with oxygen. Okay, and then, let's see, you're gonna have carbon dioxide, carbon dioxide, carbon dioxide, carbon dioxide,
Does Mandy have both?
and, okay, now what you get to do, the lungs' job is to get rid of carbon dioxide and add oxygen. Here you go. So when you get the plates, you gotta take off the carbon dioxide, throw them on the floor, and get oxygen. You are going to pull off the oxygens because you're going to use them because you're the body cell. And you get to add carbon dioxide to the plates as they come past you. Keep going.
Hey,
Go on.
I need some.
Come on, lungs. Keep it going. Keep it going.
One blood cell with nothing. Maybe it's a
See, aren't you glad you don't have to think about this and your lungs do such a good job?
faster lungs, faster.
Faster lungs. The body cell is catching up. It's taking off more oxygen than you're putting on.
We're done.
So, does everybody appreciate your lungs a little bit more now? Especially Mandy.
Good grief.
All right. Put your plates back on the table. Somebody help me pick up all the oxygen and carbon dioxide we threw all over the floor. You want to keep it? All right. And make me your little name tag piles on the table. Thanks, guys. Good job.